All right, now we're doing section 1.6, problem number 7. This is the derivative. So it's telling me the slope of the original equation. So I'm going to go up here and just kind of try to draw a sketch of it. So I'm reading values off of this graph, which are the slope up here. The derivative, the values, the height of this curve, the values it has, is telling me the slope up here. So right at -4, I get a value of 3.5. So I got a steep slope. And it goes up to 4.5 slope. And it goes down to maybe 1.5 slope, and then up to a 2.5 slope, and then down to a 2 slope, and then up to a 4.2 slope-ish, and down to a 0.6 slope, and then up to here looks like about 3.7, down to a 2.5. Notice all of these values are positive. So if this is a slope of, this is going to be hard to sketch. Let me try to sketch it here. And I'll just start any place here at -4. -4. 1, 2, 3, 4. I'm going to be way down. I'm going to start down here because I got to be going up at 3.5 steepness, getting steeper to 4.5. And then it gets less steep to 1.5, which is something like that. And then all of a sudden it's up to 2.5. And then it's down to 2. So it's getting steeper, which means it's got to curve up. Then it gets less steep, so it's got to be curving down, and then it gets more steep, so it has to be curving up. Then it has to get less steep, so it curves down. Then it has to get more steep, and then less steep, and then more steep. And so you get the idea what's going on here. So what is the approximate slope of the tangent line to this function at 2? At 2, the slope is, about 1.6 or 1.2 or 3. Just reading the height of this graph is telling the slope of this. How many real number solutions are there to the equation g of x equals 0? Well, if this thing is always positive slope, this graph is always positive, the g has to be always going up, so it can have how many real number solutions can there be for this? How many can there be? 1. We don't know beyond here. It might be doing all this positive stuff here and then turn and go up, or it might be going up here and then turning before it gets there, but it could have 1. On an interval from -3 to 3, so from here to 3, how many times does the concavity change? Well, when it's increasing slope, the concavity is up. When it's decreasing slope, the concavity is down. And then it's up and down, and so it goes from up to down, that's 1 change. From concave down to up, that's 2 changes, 3 change, 4 change, 5 change, 6 change, 7 change, 8 changes. And what's the derivative, second derivative, at 2? Well, the second derivative is the slope of this one at 2. So I'm going to go here and I'm going to draw a tangent line. Looks like it's going up 1, 2, 3, 4-ish for 1. So I'm going to estimate it is about 4.